Alright, Tracy, so I was taking a look at the other problems you had. Now, in terms of doing problems like these, so you sent over one like this where the average time for a death row inmate is 15 years. We're given 75 death row inmates. Their length of time on death row is 17.3 years, and we're given a standard deviation of 5.7. Now they ask what type of test should be run. Well, this is of a mean, not a proportion, so we'll be running a t-test. And then for our alternative hypothesis, well, our null hypothesis is saying that the average time is 15 years. Well, our alternative is saying that it's different. So for something, for a test that's different, in this case 17.3 years, they got different data, it's a two-tail test. So basically, notes right here, a two-tail test alternative hypothesis is not equal to a certain number. And in this case, it's not. Now, to calculate the p-value, all we're doing is using our hypothesis testing for a mean spreadsheet. We are given a sample size of 75. Our population mean is 15. We have a sample mean of 17.3, standard deviation of 5.7, and use an alpha of 0.05 since it's a two-tail test. If this was a one-tail test, either a left or a right-tail test, you would use 0.10. But in this instance, it's a two-tail test, so we'll be using 0.05. Now that calculates our p-value, our t statistic, and since this is a two-tail test, our p-value is right here. So 0.008. And since our p-value is less than our alpha, we can reject the null hypothesis, which another note right here gives you that. So if p is less than alpha, reject the null hypothesis, but if p is greater than alpha, you will fail to reject the null hypothesis. But in this case, 0.0008 is much less than the 0.05 alpha we used. So we can go ahead and reject it. Oh, I wonder if they wanted it rounded. Well, let's just try this. There we go. So I guess just enter the full number in case that comes up and there's a rounding error. I didn't see where it said round, so just enter the full number if that happens. Now for this question here, you are going to be required to take your own mean and your own sample standard deviation of this data set here. So right here, I'm going to go ahead and enter that data in. Now, I am given 74.4, 63.9, 96, 96, 61.9, 73.5, 85.5, 88, 83.2, 62.7, and those are all my statistics right there. Now if you want to find the sample mean and the standard deviation of that sample, I already did it over here, but I'm going to show you for technical purposes. You can go to formulas, you can go to more functions, statistical, average, and what you'll do is you can highlight this data here, hit enter, and that is going to give you the mean of your sample data. Now to get the standard deviation, same thing, formulas, more functions, statistical, and we're going to scroll down to standard deviation of a sample. So stdev.s. And again, you can just highlight the data, hit enter, and that right there will calculate your standard deviation that you will need to enter for this to calculate this data in the spreadsheet. So we are given a sample of 10 students. We have a population mean of 65, since that is the first statistics test sample. Our sample mean is 78.51. Our standard deviation was 13.140300695, and I just enter the full thing because I round at the end. The alpha in this case, it says to use a significance level of 5%, so we will use 0.05, hit enter, and all your statistics will come up. We are given our test statistic right here. So they were thinking the mean score is higher. So in that case, it's a right-tailed test because, again, a right-tailed test, the alternative hypothesis is greater than a certain number. So, while they're saying our mean is 65 for our null, our alternative is thinking that the mean score is higher. So in that case, it's a right-tailed test because our mean is greater than 65. That's our alternative. Now, state the mean of the sample. Well, we calculated 78.51, so 78.51. The standard error of the sample means. Now, this is a separate formula. I have it right here. I will go ahead and erase this. So, what you're doing is the standard deviation of the sample that you calculated divided by the square root of the sample size. So in this case, our standard deviation is I cannot get my pen to work. Eraser. There we go. Alright, so we are given a standard deviation of 13.14031, and then our sample size was 10, so square root of 10. And doing this on a calculator, 13.14031 divided by the square root of 10. And I'll show you how to calculate that on a spreadsheet. If you just hit equals, you type in 13.14031 slash SQRT parentheses, put your 10, close the parentheses, hit enter, and that right there will be the standard error for this question. So that is the standard error for the sample means. 1553. It says around the 4 decimal places. Now our test statistic is right here. 3.2512. Our p-value, well, since we know it's a right-tailed test, this is our p-value right here. So 0.004. And well, guess it'll just be 50. And since our p-value is less than our alpha, we can reject the null hypothesis. Now, for the last question you sent over to me, same kind of setup. We're just entering in our data. for this study, again, we're doing population means, not population proportion, so you'll use a t-test. Well, in this question, your mean claims your new car gets 22 miles per gallon on the highway, right? But our alternative is that the mean is less. So the mean is less than 22. That's our alternative. Well, the test statistic, again, we got to calculate all this. So our sample is the 50 trips we took to determine this 18.3. So we have 50 trips. Our population mean was the 22 miles per gallon. Our sample mean, though, was the 18.3. Oops. And then we have a standard deviation of 8.2, and they want us to use a 0.05 significance level. So our test statistic is calculated right here, and again, that did come up correct. The p-value, well, since it's less than 22 for our alternative, that means we are doing a left-tail test because alternative hypothesis is less than a certain number, so we're doing a left-tail test, and our p-value for the left-tail test is 0.001. Now that means that our p-value is less than our alpha, so that means we get to reject the null hypothesis. So again, less than alpha. We should reject the null hypothesis. In making our conclusions, we can state that the data suggests that the population mean is significantly less than 22 at alpha equals 0.05. So there's statistically significant evidence to conclude that the population mean miles per gallon for your car on the highway is less than 22. Now we got to interpret the p-value for the context study. Well, our p-value, again, was 0.001. So if the population mean miles per gallon for your car on the highway is 22, and if you drive another 50 times, so another 50 trips, then there would be a 0.1238877% chance that the sample mean for these 50 trips would be less than 18.3. Now, that's just if I took this number and multiplied it by 100. So, again, you could test this and do your p-value to get it in a percent because that's what they have here. So if I were to just enter in equals 0.001239 and I hit the shift 8, which is the multiplication symbol, and then I do 100, enter, and that will tell me what my percentage chance is. So basically it's 0.1% chance. Now, for interpreting the level of significance in the context of this study. So our level of significance was 5%, 0.05. If the population mean miles per gallon for your car on the highway is 22, and if you take another 50 trips on the highway, then there would be a 5% chance that you would end up falsely concluding that the population mean miles per gallon for your car on the highway is less than 22. So I hope this helps. Again, keep up the hard work, and I know you guys can get through these chapters.